In February 1988, the most curious physicist of the 20th century took his last breath at a Los Angeles hospital. His final words were, "This dying is boring." 13 months later, almost to the day, two chemists from Utah walked into a press conference and dropped a bomb that split science in half. They claimed they had cracked cold fusion, energy in a jar, limitless, cheap, world-changing. Within 90 days, the scientific establishment had crushed them. Their careers, ruined. Their names, a punchline. Cold fusion became a four-letter word in physics. But here is what almost nobody tells you. Buried in Richard Feynman's Caltech notebooks were the equations, a forgotten 1957 paper, a theoretical framework so quiet, so ignored, that for 35 years no one bothered to ask the obvious question. Did Feynman already know? To understand what happened, you have to go back to March 23, 1989. Salt Lake City. Stanley Pons and Martin Fleischmann stand in front of cameras and announce that they have produced nuclear fusion at room temperature, in a beaker, with heavy water and a piece of palladium. If true, this would be the discovery of the century. Nuclear fusion is what powers the sun, temperatures of millions of degrees. These two men were claiming they had done it on a tabletop with a battery. The world went insane. Stock prices for palladium tripled overnight. Governments held emergency briefings. Newspapers screamed about the end of the oil age. And then, almost as fast as it began, it collapsed. Caltech, MIT, and a dozen other labs failed to reproduce the results. Neutron detectors malfunctioned. Calorimeters were questioned. Within months, cold fusion was branded pseudoscience, pathological science, the science of things that aren't so. But here is the strange part. The story didn't end there. It went underground. Most people don't realize this. The phrase cold fusion was not invented in 1989. It first appeared in the New York Times in 1956, describing the work of Luis Alvarez on something called muon-catalyzed fusion. Real, verified, room temperature nuclear fusion, triggered by a heavy version of the electron called a muon. It was the original cold fusion, and Feynman knew about it intimately. In 1957, the same year Alvarez's group published their breakthrough, Richard Feynman co-authored a paper titled Theory of Inelastic Scattering of Cold Neutrons from Liquid Helium. Cold neutrons, the very particles you would need to understand to investigate low-energy nuclear interactions. Feynman wasn't just a quantum electrodynamics guy. He had his fingerprints on the physics that sits underneath the entire cold fusion question. But he died in February 1988, 1 year and 1 month before Pons and Fleischmann walked into that press conference. He never got to weigh in. He never got to challenge the experiment. He never got to apply his most powerful tool, the path integral, the sum over history's framework that made him a Nobel laureate. To the question of whether deuterium nuclei trapped in a palladium lattice might fuse through quantum tunneling pathways, the establishment never modelled. Think about that. The one mind that might have done the math correctly was already gone. Here is the part that should make you uncomfortable. The mainstream story is that cold fusion died in 1989. That is a lie, or at best, a convenient simplification. The Japanese government continued funding it for decades. The US Navy's Spawar lab quietly published positive results in peer-reviewed journals through the 2000s. In 2015, Google funded a multi-million-dollar collaboration with researchers at the University of British Columbia, MIT, and the University of Maryland to revisit cold fusion. Their conclusion, published in Nature in 2019, was carefully worded, but they did not rule it out. ARPA-E, the US Department of Energy's high-risk research arm, started funding what they now call low-energy nuclear reactions, or LENR, in the early 2020s. The field has new names, new labs, new billionaires backing it. Companies like Brillouin Energy and Brilliant Light Power are still chasing the dream. So what changed? Why is mainstream physics suddenly willing to look again? because newer theoretical frameworks, many of them descendants of Feynman's path integral methods, are starting to suggest pathways for low-energy nuclear reactions that the 1989 critics simply could not see. Phonon coupling, electron screening, coherent quantum tunneling in metallic lattices. These are not crackpot ideas. They are extensions of real quantum mechanics, the same quantum mechanics Feynman helped invent. So did Feynman crack cold fusion, not in the way the title suggests. He never published a paper claiming room temperature fusion in palladium. He never built the experiment. But he gave science the tools, the path integral, the sum over histories, the willingness to take ridiculous-sounding ideas seriously and test them rigorously instead of laughing them out of the room. And here is the uncomfortable truth. When Pons and Fleischmann made their announcement in 1989, the physics community broke Feynman's most important rule, the rule he stated in his Caltech commencement address. He said, "Science is what we do to keep from fooling ourselves. The first principle is that you must not fool yourself, and you are the easiest person to fool." In 1989, the establishment fooled itself, not by believing cold fusion, by being so eager to disprove it that they stopped looking. They closed the door before the room had been searched. That is the evidence science refused to see. Not a hidden experiment, not a secret notebook. A missing willingness to ask the question honestly. So I'll leave you with this. If Richard Feynman had lived another 5 years, would the cold fusion mystery 1989 story have ended differently? Would he have done the math? Would he have torn the experiment apart with the same brutal honesty he brought to the Challenger Disaster Commission? Or would he have found something everyone else missed? We will never know. But the equations are still there. The notebooks are still archived. And the question, 3.5 decades later, is still open. What do you think? Did science bury the right hypothesis or the wrong one? Drop a comment below. And if this changed how you think about scientific consensus, hit subscribe. There are more lost stories where this came from. I'm out. See you in the next one.